is a part of a line with two endpoints. Okay. So here's the deal. Today we might just be having a conversation all day together. We might not even get to our homework. We might just take notes. We don't know. We have no idea what's going to happen today. So all I need you to do is have a positive attitude to try, and we'll see what happens. Okay? That's all I need from you. We just all gotta just be a team together, and we'll figure it out. So we're gonna start off with a bit of an activity, sort of. So we're gonna use Uno cards. Everyone knows how to play Uno, right?
No.
Does anyone not know how to play Uno?
That's
why you don't lie.
Do you actually not know how?
No.
So you can either lay down the same color card or the same number, right?
Okay.
And then there's a thing called a wild card, and you get to pick what color you have.
C.
Okay.
First card.
So, if we are given a blue 5, we want to eventually prove or get to a green 9 using those cards there. So, what would you lay down first? Which 3?
The
Blue. Why the blue one?
Because it's blue.
Same color,
wow.
right?
Yeah.
Alright,
Wow.
then what would you do?
Red 3.
Red 3, same number,
The red 4.
because it's the same
color.
Yes.
And then
Not the green 4.
The green 4, same color, which then we can end with the green.
It's same number. Same color.
Oh, I'm sorry, guys. You understood, right?
Yeah.
You're good? Okay, so that was pretty straightforward, right? Kind of like last week's proofs. Let's see another one. So we are given a yellow 0, and we want to prove or get to a red 6 using those cards. Formulate a plan, think what you do. Say that you don't want to be with me. So think what you would do. What cards would you lay down first?
0.
And tell someone sitting next to you quietly.
It's 2006.
When do we break up the wild +4?
It's coming out.
Why is there a Q?
It's a 9.
What?
What card would you lay down first?
blue 0.
Blue 0. Then what?
Blue 9.
Blue 9.
Then green 9.
Green 9. Is
Going too fast.
Green 6.
that what you guys all came up with?
Yeah.
Okay, let's just see. I don't know how many I have on here. Okay, use all of these cards. You have to use all of them.
Wait, no. 2.
Have to use all of our
Yeah.
cards.
Yellow if I want to go 8,
let's-
8, and
Well, because
Yellow.
yellow 2 has to be
yellow 2, and then yellow 2, green 2.
Can you use all of them?
Yes.
Sure, which one would you start with?
Yellow 2.
yellow 2.
Do you have to start with the yellow 2?
No. You can start with green 2.
You could. Okay, now what?
Green 2. I want to go green 2 first.
Blue 8.
Thank you, Wyatt.
That was
Why don't
good.
we do the green 2 first?
It doesn't matter. I mean, you could. It would
Yeah, you could
make
go
a difference.
8, 2, 2, 2.
So this is what we'll find out later, that there'll be different ways to write a proof now. It wasn't so step by step like your algebraic ones, because we've been solving algebraic proofs for so long that we just know what to do automatically, right? Whereas now we'll be like, oh, I get to choose. We'll have a little maybe different proofs than our friends. I think there's one more. Oh, there's your wild. Okay, this is our last one, I think.
Wow.
Try this one. If you have to use all of these.
I use the wild card and then
Wild,
4, 8,
That's the only way it works.
You can go 8, 4.
No, you couldn't.
You cannot go 4 or 8 and then 4, because then how would you get from the green 4 to the
Blue 8. Yeah, that's not very Wow, is that a good point?
Which one do we have to lay down first?
Wild
card.
And then what card would you play?
The 4.
4.
Then the green and the blue.
Yeah.
Yes, Lou.
Okay, so just today, remember, this is really the big idea. This is all you're doing, okay? So don't get too caught up in the math. We just have to have a reason for what we do. All right? Okay, I think now we're into our notes.
Exciting.
Okay, so this is a review. This little first chunk on that green sheet is a review from Friday. All of those properties we use all the time. We add, subtract, multiply, divide. You already know those things, but will you do me a favor? Will you either write it down or highlight this part here that we used all of these properties with an equal sign? Or maybe bold this part here. Properties of equality. And the way it tells you, just look at the equal sign. There's an equal sign there, it's equality. Because now we're going to shift into when we have a congruent symbol. And remember, that looks just like an equal sign with a little squiggle on top, right? That's a congruent symbol. So now for congruence, we have the reflexive property. Remember, that's just the same thing equal to itself. The reflexive property. So segment AB is congruent to segment AB. Same thing equals itself. Remember, for our symmetric property, we just flip the order, right? So if I had two segments, if I had segment AB, is congruent to segment CB, I can just swap out that order and it means the same thing. That segment CB equals. And then the good old transitive properties when we have our three things. All right, so AB equals CD, CD equals EF, so then we know we can jump from our first to our last. And they are both equal to the same thing. Remember, those are used with a congruent symbol, non-equal symbol. Okay, now we're going to have a definition. So it says definition of congruence. Now this is really silly. It seems kind of silly that we have to do this. If we are told two segments are congruent, segment A, B, and CD are the exact same, then this is saying then their measures are the same. It's just like a technicality. It's just kind of a weird thing that we have to talk about. And then the other order works. If we know that their measures are the same, then we'll know that they're congruent. And we'll see a couple examples of that today why that's important. What's the midpoint? The middle of what? Of a segment. So if we are given that something's the midpoint of something, good work. M's the midpoint of AB, then I know AM equals MB. If you want to draw yourself a little picture, here's A, here's M, B, then I would know that AM is equal to AB. Then we have one more reason to talk about. So segment addition. Did you hear Glenn?
No.
So what's my whole thing? AC, right? And what two chunks make up AC?
A, B, C.
Yeah. So that's all the segment addition is. We've done that before. We just haven't given it a name. So segment addition is just what two parts make up the whole thing. So now this green sheet, that's why I have it on a different color. This is your reasons. These are the only things you'll have to look at when you write a proof. Like this is going to be like your same color or same number like in Uno. This is it. This is your guide, okay? Just keep this open when we do our homework and stuff. So we'll just look at it here. Are you ready?
No.
You gotta write it through?
No.
I'm excited. We're gonna start with some training wheels. They're not gonna be you just making the whole thing on your own. So step one is you're gonna look at your given, but then you gotta mark your picture. So if I look right here, it says given E is the midpoint of DF, what do I already know about this, just this picture, before I even look at anything else? Yeah, it's in the middle, right? So then I know that DE is equal to EF, so will you mark that on your picture? I want you guys to get in the habit of marking your picture. So I somehow have to find my way to say 2 of DE is equal to the whole thing of DF. I think we know that, right? We know if I added 2 of the same thing, it would give me the whole thing if both parts are equal. But the hard part is formulating the correct argument. So today we're going to be given proofs like this, and we're just going to have to fill out one of the parts because we've never done this before. So it says E is the midpoint of DF. What would be my reason for that?
Yeah, that's a good.
That's just a given, right? Remember, you always start with your given. So you guys write that down. And then it says DE equals EF. But why do I know that DE is equal to EF? Definition of a midpoint, right? What's my...
abbreviated?
Sure, that's fine. Definition of a midpoint. And those two things are equal because we were told E is in the middle. So now if we look, I'm jumping from 2 to 3. What's different between this line here and this line here? What doubles though? So what symbol did they use? They added DE to both sides, right?
Yeah.
So what property? Addition property. Okay, now if I'm looking from 3 to 4, what's changed?
They simplified.
What side did they simplify? Yeah, look, I have 2DE, so if I combine like terms, I have 2DE. Sweet. That works. We just simplified. And then we're told DE plus EF equals the whole thing. DF.
Subtraction. The segments.
Right? Look, this chunk plus this guy gives me the whole thing. What property is that? Segment addition. Like for instance, that's a good example. Really, these two steps aren't right after each other, but I can just say that. I mean, you can just sometimes say things. And then if we look, we jump from 2DE to 2DE. And then I have DEF and this guy. Those are the same.
Isn't it the definition of congruence?
I highlighted those things. So if I look over here, guys, 2DE is equal to DE plus EF. Then we're told DEF plus EF is equal to DF. So what can I conclude about these two things? They're the same, right? Because they're equal to the same thing. So that's the transitive property. And I know these are weird, these are hard, but when they click, you'll get it. Okay, our next one, let's look at our picture here. It says KL is congruent to LN. And then we're told LM is congruent to LN. So what do we know about all three of those little segments? They're all congruent, right? And then we want to prove that L is the midpoint of KM. So again, I think we can reason through it ourselves, like, yes, obviously that makes sense, but the hard part again is writing the proof to prove it. So what do we always start with?
Given.
Our given. And then it says KL equals LN, LM equals LN. So that's, yep, do you guys see how we just kind of lost the segment bar on top? Yep, good work. So definition of congruence. KL equals LM. Transitive property, right? Because they're both equal to what? LN, so therefore they're the same. So what can we already say? Definition of the midpoint. So if this is the same as this, then that makes L in the middle. How about you guys try the next one? See what you can figure out on your own. See if you can work through it. If you're totally lost, that's okay. I expect us all to be lost, to be honest. If anything out of those 5 spots you have to fill out, or like 6, no, just 5, you already know what the first statement is, because that's what you're given, and your last one's what you're trying to prove. So you just gotta try to figure out 2, 3, 4.
Popular groups.
No, it's Callie. No Callie's. So she does it. She says sorry.
We already know those go there for sure, right? So if you have nothing else on a test, you give me that, that's what is the point, right? You know for sure that those are givens and what we're trying to prove. What? Yeah, and if you draw in the picture, that's the other point too. Did anyone finish it? Or are we still kind of working through it?
We have one left.
I'm just
Got one left?
I got it.
So our next reason says segment addition postulate. So if you're like, what is that? Go back to your green sheet and refer. What does a segment addition postulate look like? What's that? Yep. So the two parts of your segment equal the whole thing. So what are my two parts going on here?
PQ plus QR.
Yeah. So I have PQ plus QR, and that's equal to the whole thing, PR. All right. Then it says 2PQ equals PQ plus QR.
Simplify.
Simplify?
No, it's the transitive property of congruence.
Why?
Because it's saying that 2PQ is equal to.
Hey, look guys right here. I have PR equals something and I have PR equals something. What are they both equal to? Right here. So I can set now those two parts equal to each other since they both equal PR. You see that? PR equals 2PQ. PR equals this whole thing. Well, then I know that this chunk has to equal that because they're both equal to PR. So that is the transitive. And 3 to 4 is kind of tricky. What did anyone get anything for that?
Subtract.
Oh, subtraction?
But you go from 2PQ to PQ and you lose PQ.
I lost my PQ over here, right? And I had 2, and then I only have 1 left, so I took 1 away. So that's a subtraction property.
Nice job.
That was good. Okay, why don't you grab out an Expo marker? We're going to do some on our desk together. We're just going to keep practicing all day. It's one big group.
Practice all day when we stop.
We'll see. If we don't get to it, we don't get to it, and if we do, it's 2 problems, 3 problems. We'll see. I'm not sure.
Yeah.
Okay, so what I would do if I were you, draw the picture and mark it. I wouldn't write down all the extra stuff, but draw yourself a nice picture so you can see what's happening. Then mark up your picture. So PQ is congruent to PQ. This guy equals that guy. UQ is equal to QS. So in layman man's terms, guys, I have 2 different segments, but they're both made up of the 2 same size pieces. So when you think about it, does it make sense that those 2 segments would be the same size? It should. So you guys take a moment, see what you can figure out of those 7 reasons given the blue options. You don't have to write out both sides if you don't want to, unless that makes it easier for you, then that's awesome. If not, just do what works. Yeah, help each other for sure. And then I have this right here, but then I swap out PQ for TQ. So right here, I switch these two out. So that's substitution. Super close. This does not say English. This is one that's our saving. That's giving us years of open. It's not sending it up. These two. Good. Now look right here at PS equals QS. Right, this is a part that changed. And it changed because there's both of them. So I just swapped those out. So replace something for something that's equal to is just substitution. Okay, let's look at this together. So we started with our given. Then what happened between steps 1 and 2? What happened to our steps?
Definition of congruence.
Yep, we got rid of the congruent symbol and our segment bar. So that is right here. Now steps 2 and 3 really don't relate, but what's happening in 3?
Segmentation.
So just break it apart. It says PS equals my 2 chunks, right? And then TU equals the 2 chunks added together. Well, we know that is segment addition. Now, if we notice here, folks, look. PS equals PS equals. QS, QS. But what changed? My PQ swapped out for TQ. But I know that they're equal, right? So what property is that when you switch something out for something else?
Substitution.
Yeah. We just switched something out that was equal for it. And same thing here. TU equals TU. Oh, QS for QU. Well, I know they're equal, right? So that would be what?
Substitution.
Substitution. And then if we notice, do you guys see how these match? So then what can I set equal to each other because those match? Yeah, awesome. And then back to definition of congruence. Were we close?
Not really.
No? We'll get there.
You know
We'll
what?
get
You
there.
tried, Wyatt.
That's all I
I
care about.
Well, I mean, not really. I kind of put a frowny face on 4, 5, 6.
I'm going to try to cover the reasons on this one. I'll eventually show them, but see, just see.
Oh no.
Except I'm going to give you one, because one's really weird.
Are you gonna give us the game?
No.
Memorize.
Let's just see what we can come up with. Essentially, we're told that all those little pieces that make up that V are equal. And we want to show that KL equals LM.
Why are there some?
Did they list all 3 givens in the first box? Right? That's another given.
Oh, wow.
They just wait to say it later.
Yes.
Mind blown?
Yeah.
Let's just. Oh. Yeah, no, symmetry.
Oh, number 2 is the onset or the segment addition. Right?
So you can do it.
Oh,
Try it again.
wait. Is number 2 definition of midpoint?
Yeah. Guys, 2 is definition of a midpoint because we're told that K is the middle. Well, if K is the middle of JL, that would make JK equal to KL.
Yes.
Definition of midpoint. It's one hour homework and the other 2 are supposed to do. Okay, so it's not
Final answer.
close. We'll get some times.
Yeah.
One problem is number one.
Congruence is going from no lines to lines or from lines to no lines? No.
So for we had 67 next year, they'll just say the bar. That's
If I would have known that, I would have put it at 7.
This is the homework.
Yep, and then there's 2 problems in your book I want you to try in the back.
He was like,
No,
Wait, what's number 6?
You're not a chief.
Wait.
Oh, yeah.
There's no way I survived.
definition of they're actually shocked. Not even kidding, that actually hurts so much. Would this be the segment addition? No, this is the definition of the midpoint. No.
This one?
That's not midpoint. Yeah. So then I think this would be the segment addition. So how can I?
Yeah, that's
So substitution.
To the MN and MN. So if they're both equal to those two, then I know they're equal. So transfer.
That's right. I like basically. And then when you transfer, I think so. And then definition. This is probably all around it. That's why 4. You treat it out as
That was actually so easy.
Miss Bundy,
Yeah, buddy.
this way.
Yep, come on.